All right, so very good evening to all of you. This is your educator Srishti, and I welcome you all on Unacademy's YouTube live channel of IIT Jam. And I'm mentoring IIT Jam chemistry aspirants on Unacademy's Plus platform. So, in the previous class, we have started with the PYQ series. That is, we are going to discuss each and every previous year question from your IIT Jam chemistry section, and we started with chemical kinetics. Okay, so in this particular session we'll be starting again with chemical kinetics, and we will be discussing previous year questions from chemical kinetics. Okay, so without the further ado, let's begin with our session. So very good evening to all of you. Good evening Arun, good evening Siva. Right, so now let's begin with our session. So there you have very first question in front of your screen from chemical kinetics. Okay, so just take your time, analyze the question, and then give your answers in the comment section. So we are going to discuss each and every previous year question in much detail. Okay, so just take advantage of this series and right and solve each and every question with proper time. Okay, so Arun, can you please tell me, slide is visible, questions are visible to you? Questions visible, can you please tell me? I think questions are not visible. Right, so am I audible to you now? Nisha, or Mosmi, Arun, Sonia, am I audible now? Let me inform the students first. Amazing, right? So let's wait for 30 more seconds, Nesha, so that your friends can also join this session, and then we'll just begin. Okay, so I'm really sorry for this technical issue. Actually, the screen was not working. Okay, so I have to pause the video and restart it. Okay, so now I think everything is visible and audible. So again, I'm welcoming you all in this YouTube session of Unacademy. In this particular class, we will discuss the previous questions of chemical kinetics. We have discussed some questions from 2020 year, and in this particular session we'll be continuing our question discussion from chemical kinetics. Okay, so without the further delay of time, let's begin with our session. So first of all, you have this question in front of your screen. Okay, you have to analyze this question carefully and then give your answers in the comment section. Okay, all of you have this first question in front of your screen. Okay, read this question, very easy question. You can just give this answer in fraction of seconds. Okay, so I'm waiting for your answers. Right. Amazing Anandya, amazing Nisha, amazing Arun. Yeah, the correct answer over here is option number A. Okay. So let's discuss this question in detail. So this K, okay, first of all, we are talking about the rate constant. Okay. Definitely we are talking about the rate constant. So how you can find out the order of reaction with the help of units of rate constant, that is the main agenda of this question. So definitely whenever you have to find out the units for rate constant, the formula is K is equals to concentration to the power 1 minus n and time inverse. Okay, so what you need to do for order is equals to 0. Okay, for order is equals to 0, always the rate constant unit is mole per liter. Okay, the rate constant unit is mole per liter per second, and for order is equals to 1, the rate constant unit is second inverse, and for order is equals to 2, the rate constant unit is mole inverse liter second inverse. So this is the application of rate constant units, and definitely from this expression you can see that the unit is mole per liter second inverse. So definitely the order is going to be option number A, that is zeroth order reaction. I think this question is clear, right? It's pretty easy and straightforward. So let's take the next question now. This is your next question. Yeah, very good evening, Samba. So let me read the question. The question is the half-life of the chemical reaction. This is your chemical reaction for the initial reactant concentrations of zero point 0.1 and zero point 0.4 mole per liter at 200 seconds and 500 seconds respectively. The order of reaction. You need to calculate the order of reaction. Okay. So let's see how many of you can get this question absolutely correct. Again, it's a straightforward question. Okay. So the questions from chemical kinetics are straightforward. So definitely you can apply the formula and you can get the answer. Right? So I'm waiting for your answers. All of you just solve this question. Okay, Anand is giving answer C. Let's see. Any other answer for this question? Amazing, amazing. Right. So the correct answer over here is option number C. Let's see. So first of all, you have this direct formula. Whenever you have two types of half-lives and you have two types of concentrations corresponding to that two half-lives, you have a direct formula. The direct formula is, right, T half 2, T half 2 divided by T half 1 is equals to A naught 1 divided by A naught 2 to the power of n minus 1. Okay, this is the way you have to analyze this particular question in detail. Okay, T half 2 divided by T half 1 is equals to A naught 1 divided by A naught 2 is equals to n minus 1, right? So now here T half, let's substitute the values. T half is equals to, right, to zero point 0.4. Okay, this is 50 seconds, this is 200. Okay, this is 50, this is 200, this one is zero point 0.1 and zero point 0.4 to the power 1 n minus 1. Okay, so this is now 1 by 4 is equals to 1 by 4 to the power n minus 1. Since bases are same, whenever bases are same you can equate the powers, right? So 1 is equals to n minus 1, so order is going to be 2. So it's a second order reaction. Again, a direct question, and the correct answers over here is second order reaction. Right. Very good, Nisha. Very good, Sambhav. Very good, Anandya, Sushil, Vishnu. All of you, your answer is absolutely correct. Okay. So let's take the next part. Okay. It's okay. Mosmi, let's do this next question. This is the question based on turnover frequency. You need to calculate the turnover frequency. All these are jam previous year questions. Okay, and I'm very sure now these questions are very easy because we have discussed chemical kinetics in very detail. Okay, so now you need to find out the turnover frequency. So let's see what all things are given to you. Concentration of catalyst is given to you 0.01 mole. Time is given to you 5 hours. Okay. Concentration of initial A substrate is given to you 1 mole. Okay. With 90% yield of product, it's given to you that the yield of product is 90%. Okay. So you need to calculate the turnover frequency in the units of R inverse. Okay. So let's see how many of you can get this question correct. Yes, everyone, what's your answer for this question? Nisha, Sushil, Vishnu, Sambhav, Anandya. Okay, 18R inverse. Any other answer for this question? Yes, any other answer for this question? All of you are going with 18. Let's do this now. Okay, so first of all, what you need to understand, right, Pratiksha? 18R inverse is the correct answer. Okay, so let's see how we need to solve this question. Basically, whenever the question is on turnover frequency, so you need to remember the formula, but you need to understand the formula, which is more important than remembering the formula. Okay, so the turnover frequency is equals to number of moles of reactant which is converted into product. Okay, those moles you have to take which has been converted into product, divided by concentration or number of moles of catalyst into time. Okay, divided by number of moles of catalyst into time taken. So now what you need to understand in this question is number of moles or concentration of reactant which is converted into product. So it's given that 90% yield of the product. That means if 1 mole is the initial concentration of reactant, so how much product now you have? Definitely you have zero point 0.9 moles, right? This is the 90% of 1, so you have 0.9 moles of reactant which has been converted to product. So definitely this value is zero point 0.9. Definitely this value is zero point 0.9 without any second thoughts, right? Next is number of catalyst. Okay, the number of moles of catalyst, so definitely it's also fixed 0.01. Okay, and the time is 5. So now let's do this calculation. It's very easy now. Zero point 0.9 into 0.01 into 5, which is 0.05. Okay, so definitely this is your answer. Okay, that means 18. Okay, the answer is 18R inverse. Definitely the correct answer is 18R inverse. So turnover frequency is 18R inverse, right? You all guys have given me the correct answer, that is 18R inverse. So that's amazing. Okay, let's take the next question now, right? This question is from IIT Jam 2019. Okay, let's move to now 2018 questions. So this was a question asked in 2018 in IIT Jam chemistry examination. So let's see how many of you can get this question correct. So the question is, a reaction A to products follows first order kinetics. If A represents the concentration of reactant in time t, the incorrect variation is shown in. So you need to calculate, or you need to find out which of the following graph is incorrect in nature. Okay, so all these 4 graphs have been given to you which is following the first order reaction. You have to find out incorrect with right between all these 4 options. Okay, let's see who all can do this question in less time. Okay, that is important. We have to maintain and we have to follow the time management also. Okay, so let's see how many of you can get this question correct. Now you need to find out which of the following graph is having incorrect variation for first order kinetics. Great. Very good, Anandya. Any other answer for this question? Yes, everyone give your answer. Sambhav, Nisha, Sushil, Vishnu, Pratiksha, Mosmi. Yeah, B is the correct answer. All of you just solve this question. Great. So let's understand this question in detail. It's very interesting, right? So let's see how we are getting to the right answer. So the correct answer is definitely B option. Okay, so let's see. First of all, this is a graph of first order kinetics. So what you need to understand for that, this graph, that is option number A graph, is having the variation between concentration of reactant versus time. So what's the reaction which is involved for this variation? The reaction is A is equals to A naught e to the power minus kt. This is the reaction which is having this relation of reactant concentration and your time concentration. Okay, so now if I increase the time, okay, if I increase the time, what will happen? If I'm increasing this temperature, not time, if I'm increasing this temperature, so definitely, okay, definitely the concentration of reactant is decreasing. Okay, so the concentration of reactant is decreasing with increase in T. Okay, so definitely this option is absolutely correct option. Okay, now next we have option number B. Okay, this option is between minus dA by dt versus concentration of substrate. So minus dA by dt, how I can write down? If A giving B is your reactant, so if I want to write down the theoretical rate, so that would be minus dA by dt. Okay, minus dA by dt is equals to the experimental rate, that is K A to the power 1. Okay, now what you are understanding or observing, that with increase in A, if I increase the A, this RHS side is increasing. If this RHS side is increasing, then definitely the increase will be there in LHS side also. Okay, but what you are observing over here, that minus dA by dt is decreasing, it's not increasing. Okay, so definitely the correct answer over here is option number B, which is not following the trend. But let's talk about option number C and D. So definitely in option number D, what you are observing, that this graph is between minus dA by dt versus time. Okay, so minus dA by dt versus time. So if I'm just writing the observed rate or the theoretical rate is equals to experimental rate, that is KA1. Okay, and what is A? Definitely this A is A naught minus KT. Okay, definitely I can represent or expand this A in this term. So now minus dA by dt is equals to KA naught minus KT. So if I'm increasing this temperature, not temperature, time, if I'm increasing this time, so what will happen? Definitely this part is increasing. If this part is increasing, so this part is going to decrease. Definitely if this part is going to decrease, okay, so definitely this part will also decrease. Okay, this part will also decrease in this particular case. So that is how you have to see this particular question. Okay, so the correct answer over here is option number B. Okay, which is your correct answer. So let's see option number D also, log A versus T. Okay, log A versus T. So what's the expression of first order reaction? The expression for first order reaction is log A is equals to log A naught minus K 2.303 by T. Okay, so now what you are understanding, if you are increasing the time, so this particular part is decreasing and this whole term is decreasing. So if it's decreasing, so definitely this is equals to y is equals to mx plus c. So this graph is also correct. Okay, first graph is correct, C option is correct, and D option is correct. Just the incorrect statement over here is option number B. Okay, so this is following the same trend, that is A equals to A naught minus KT. This is also minus dA by dt is equals to K A naught e to the power minus kt, okay, and this part also it's an incorrect statement. So definitely the correct statement over here is option number B. Now let's take the next question, and this is your next question. Let's see, right, how many of you can get this question correct. So let's read this question. The question is, the time for 50% completion of a zeroth order reaction is 30 minutes. That means T50 is given to you, or T half is given to you, 30 minutes. Right? Time for 80% completion of this reaction, you need to calculate T80 in minutes. Great Pratiksha, 48 minutes is the correct answer. Amazing, right? Great Sambhav, 48 is the correct answer. Yes, everyone, give your answers. Very good, Sonia. So let's discuss this question. So it's a zero order reaction. Then definitely the reaction is A is equals to A naught minus, okay, A is equals to A naught minus KT. This is your reaction for zero order reaction. Now T50 is given to you. What's half life for zero order reaction? That is A naught by 2K. Okay, this is the half life for zeroth order reaction. So A naught by 2K is equals to 30 minutes, right, is equals to 30 minutes. That means if I need to calculate the value of K, so that would be A naught by 60. So K value is A naught by 60. Now what we need to find out, we need to find out 80% completion time required for this 80% completion. So again I am using that same equation for zeroth order reaction, minus kt, okay, here k is equals to a naught minus 60. So I'm taking that a is equals to, right, a naught is equals to 100 and a is equals to 20. Why? Because 80% completion, 80% completion means 80% of the reactant has been converted into product, so the reactant left is 20%. So this is now 20, 80 minus k, and in place of k I am writing 100 by 60 into time. So once I do this calculation, okay, so the time will be definitely 48 minutes. So the correct answer over here is 48 minutes. So I think all of you are clear with this question. Any doubts over here? Please comment down in the comment section if you have any kinds of doubt. Is this question clear, everyone? Right, I think most this question is clear to all of you. Now we have completed questions from 2020, 2019 and 2018 year, okay. In the next session, okay, so if it's not, I think it's visible from my end. So maybe Sonia, you are facing some internet issues. Right. So we have completed the questions from 2020, 2019 and 2018 year from IIT JAM previous year section of chemical kinetics. Okay. So now in the next class we'll be continuing with this series, and I'll take more questions from the previous years, and we will try to sum all questions in next class. Okay. Possibly we'll take all questions in next class, and then after that we'll start with the next chapter. Okay. So please revise these concepts, okay, and practice this question enough. So this is the Telegram channel. Those of you who are joining this session for the first time and they want to get updated for their notifications of upcoming classes, and their notifications of YouTube sessions. So definitely you can join this Telegram channel. The name of the channel is unacademy_SBATRA. And if you want to see my special classes, so definitely in the description box you have my profile link. You can just right click on that and you will be redirected to the Unacademy's profile page, okay, and you can watch my special classes. And if in case you want to prepare IIT Jam, okay, and you want to watch my live classes also on the Plus platform, so definitely you can take the subscription, okay. The referral code is SBATRA. You can use this referral code SBATRA for 10% discount, and you can choose me as your personal mentor, okay. So this is all about this particular session. I hope you have liked this session. If you like this session, if you did, so you can just comment down in the comment section, and if you have any kinds of doubt, you can drop your doubts in the comment section. I'll take those doubts in the next class, okay. So you can join the Unacademy Telegram channel for get updated for the upcoming special classes, okay. So this is about this particular session. A very good night to all of you. Revise all the concepts, okay, and practice hard. So I'm going to meet you in the next session. That will be on 7th, right?